All right, welcome back everyone to the deep dive. Today we're really going deep on scale chains, digging into the source material you sent over. The goal here, let's try to get a really clear picture of what these chains actually are. Peel back the layers on how they work and figure out what makes them, well, a different way to get at Web3 compute power.
Exactly. And what really jumped out from these sources right
Yeah.
away is this core idea. Scale chains are designed to be like these dedicated individual instances of Ethereum. They call them chains. And they're specifically built to make developing and using dApps simpler. Yeah, but also way more cost effective.
Right, and that cost thing, that points straight to one of the biggest benefits they talk about, getting all that EVM compute power, but with zero transaction fees. That feels like a massive shift from how things usually work in Web3, doesn't it? It seems pretty foundational to understanding scale. So let's start right there. You mentioned mini-Ethereum's chains. What does that actually mean in practice? What's the core idea?
Okay, so think of an A's chain as like a dedicated blockchain within the bigger scale network. Its main job, based on the sources, is giving a dApp its own EVM execution space, its own decentralized storage, basically the horsepower it needs to scale up. And crucially, it does this without the dApp having to fight for block space or pay gas fees for every little thing, like on, a shared chain.
Okay, so it's not just like another layer 2 sitting on top of Ethereum. It's more like getting your own private lane on the highway, but that lane still connects back to the main road somehow.
That's actually a pretty good way to put it, yeah. You get your own dedicated resources, predictable performance, and super importantly, that zero-fee environment for people actually using the dApp running on that specific chain.
Okay, I think I'm getting it. But let's unpack this a bit more. How does that private lane, that single scale chain, actually get, built and powered? What's really going on under the hood?
Right. The sources describe a pretty fascinating setup. Basically, each chain runs on containerized technology, being Docker containers. These containers are then deployed and run across a specific group of nodes.
Containers, okay. And how many nodes are we talking about for just one chain?
For one single scale chain, the containers get provisioned across 16 nodes, and these are randomly selected nodes.
16, okay. And that's 16 out of a much bigger pool, I assume.
Oh, absolutely. Those 16 are picked from this larger network of, get this, over 120 supernodes. And these aren't run by just one company either. They're operated by more than 45 different independent validator organizations. So you've got this big distributed network supporting each individual chain.
Wow, okay, over 120. That sounds pretty robust. How is that whole system kept secure then?
The whole network, yeah, including how those supernodes are chosen and run, it's all secured using proof of stake. That stake comes from both validator and delegator communities, so the supernodes are sort of dynamically providing these containerized resources where they're needed. For those 16 nodes assigned to a chain, they each run these containerized network clients, so let's just call it scaled. And that scaled software has the EVM plus everything else needed to actually operate the chain.
So these 16 separate nodes, each running its own container, they're essentially working together to form one single coherent chain. How do they stay synchronized and agree on the state of things?
Exactly right. All 16 of those scaled instances are constantly talking to each other. They're broadcasting messages, sharing transactions, blocks, cryptographic data, the works. They act together as one high-performance, scalable version of an Ethereum-compatible network. And to reach consensus, agreeing on the order of transactions and blocks, they use this really fast, mathematically proven method called Asynchronous Binary Byzantine Agreement, or ABBA for short.
ABA, okay. Got it. Not the band.
Yeah, no, definitely not. But what's really interesting here, when you look at all these pieces together, you've got the containers, the random selection from this big decentralized pool, the proof-of-stake security, this ABA consensus. How they all combine is what delivers these powerful but also isolated instances of an EVM chain. And the sources make a good point. You don't necessarily need to be an expert on every single crypto detail like secure enclaves or specific signatures just to use a scale chain. But understanding this underlying architecture, it really shows why it can offer the kind of performance and security it claims. It's like a complex engine built to provide a much simpler user experience.
That's a really good way to think about it.
Yeah.
Like enjoying a smooth ride in a performance car without needing to be the mechanic who built it.
So speaking of that smooth ride, how does a developer or even an end user actually interact with one of these chains? After all that complex tech setup, the source material literally says using Scale is easy. How does that actually happen in practice?
Yeah.
Well, remember, the main goal is to power dApp apps with their own dedicated resources. And the sources really emphasize that the experience is designed to feel just like working with Ethereum. as you work with Ethereum, I think was the phrase.
Okay, so familiarity is definitely key there.
Yeah.
But what's the actual technical hookup? How do you connect?
For the owner of a SKALE chain or a developer building on it, they get access to a set of 16 available RPC endpoints for that specific chain.
Wait, 16 endpoints just for one chain? That seems like quite a few.
Yeah, it gives you good options for things like load balancing and redundancy, right? And the actual integration part. It's really straightforward. You just plug one of those endpoints into your usual Web3 client, like MetaMask, or into your developer config files for tools like Hardhat or Foundry.
Whoa, hang on. This is where it gets really interesting for me. So you're saying underneath all that heavy-duty architecture we just talked about, the containers, the random nodes, the validators, ABA, the actual step for a developer or user is just plugging in an endpoint address. That level of abstraction, making something that sounds pretty complex accessible through just a simple API, that's powerful, isn't it?
It really is. It's clearly designed to dramatically lower the barrier to entry. Developers who are already building stuff on Ethereum can pretty much stick to their existing workflows and tools.
Okay, that makes a lot of sense. So we've got this technical foundation, we've got this ease of access. What are the specific capabilities then? Like the key features you actually get when you're using a SKALE chain?
Yeah, the sources laid out several key features. First off, it's a decentralized and permissionless network. Your dApp runs on a chain that's supported by that pool of validator supernodes, right? And they're randomly selected and rotated over time. The ability to just get a chain like this without needing permission from some central gatekeeper, well, that relies on the Ethereum mainnet itself for the overall security and that permissionless access to the whole network's resources.
And yeah, permissionless access is pretty much table stakes for real Web3 infrastructure. You need that.
Absolutely. Then there's what they call flexible chain administration. The sources mentioned that a SKALE chain can be run by just one group, or maybe a community, or even a DAO.
A DAO, just quickly for anyone listening, that's a decentralized autonomous organization, right? Where the community holding tokens manages things, not one company.
Precisely, yeah. And this flexibility means projects get different options for decentralization, for how the chain is funded, how it's operated, maintained. It lets projects pick the model that fits where they are, their needs, their maturity level. It's a recognition that not everyone needs the exact same governance setup right from the start.
That makes a lot of sense. Okay, what about moving stuff, like tokens or data between these chains, or maybe back to Ethereum?
Ah, right. That's handled by the easy cross-chain integration feature. It uses the Ethereum and SKALE IMO bridge. IMO stands for Interchain Messaging Agent. And this bridge lets you move tokens, sure, but also state and even messages not just between Ethereum and SKALE chains, but also between different SKALE chains themselves. And the sources get specific here. They say this bridge is secured by stake, by secure enclaves, and also BLS threshold cryptography. Remember those complex crypto terms we mentioned earlier? Things like secure enclaves and BLS crypto. Turns out they're actually what make this bridging mechanism secure and robust.
Ah, okay. So those technical bits we didn't need to know just to use the chain. They're actually super important for making sure you can securely move things between chains. That connects the dots nicely. And bridging is just essential these days in a multi-chain world, isn't it?
It really is. And finally, a huge one, especially for developers, is the Web3 RPC API. This is why existing dApps can potentially migrate with only minimal code changes. It means developers can keep using the standard, familiar Ethereum tools they already know and, frankly, probably love. Tools like Hardhat, Foundry, MetaMask for wallets, Remix for coding.
Okay, so the significance there is massive. It means developers aren't getting locked into some proprietary system or forced to learn a totally new way of doing things just to get the benefits of a SKALE chain. That must dramatically lower the barrier for people to actually adopt it and build on it, right?
It absolutely does. It's clearly meant to be an easy on-ramp for the existing Ethereum developer community.
Right. Okay, let's maybe zoom back out for a second and just quickly recap the main things we've pulled out from the source material today. If someone asks, what are SKALE chains? What are the absolute need-to-know points based on this deep dive?
Yeah, okay. If you're trying to get a handle on SKALE chains, the core ideas from these sources really boil down to this. They're like dedicated zero-fee mini-Ethereums built specifically for dApps. They run on container tech, spread across 16 randomly chosen nodes, drawn from this big network of over 120 supernodes, run by more than 45 different groups. Security comes from proof of stake, and they use that super fast ABA consensus. But despite all that tech, they're designed to be easy to access, just simple endpoints. And they offer these key features: being permissionless, allowing flexible admin setups, including DAOs, having secure cross-chain transfers using that SKALE Chains bridge, and crucially, maintaining full compatibility with standard Ethereum developable tools through their Web3 RPC API. That last one really helps lower the barrier to entry.
Got it. So it really sounds like a mix of some pretty serious technical innovation happening underneath, but paired with a very clear focus on making the developer and user experience as smooth as possible on the surface. Okay, as we wrap up this deep dive, here's maybe a final thought for you, the listener, to chew on, something that arises from this material. Given Scale's specific approach, this focus on dedicated chains, zero transaction fees, easy integration with existing tools, what does this model suggest about the future of scaling specific applications in Web3? How does this idea, providing these isolated high-performance zones for each dApp, compare, philosophically and practically, to other scaling approaches where everyone shares the same limited block space, which can lead to congestion and those high fees we talked about? It's definitely a distinct vision for where demanding Web3 computing and data storage might end up living. Something to think about.